In this problem, we have a 10 kilogram crate. Initially, it is already moving to the right with a speed of 3 meters per second. And it has an applied force, which is a function of time, that's applied on it at an angle 30 degrees with the horizon. The coefficient of kinetic friction between the crate and the surface is 0.15. Now we need to determine the speed of this crate after 6 seconds. Again, we can use Newton's second law coupled with kinematics to solve this problem, but in this case, we are going to use the principle of linear impulse and momentum to solve this problem. So if this is our, again, a conventional x and y direction, then along the x direction, linear momentum mv1x plus the integration of the total force along the x direction integrated with respect to time equals to mv2x. So mv1x is known, and that is your 10 times 3 initial velocity along the x direction. And if we can find the total fx, and then as a function of time integrated with respect to time from 0 to 6 seconds, and that will equal to our mv2x, which is 10 times our unknown that we need to solve for. So let's look at the force analysis. So we start with the free body diagram of this crate. It is subjected to its own weight, and that is 9.81, 10 times 9.81, so 98.1 Newton. And then this force right here, let me resolve it into x and y components. So along the x component, that will be f times cosine 30 degrees. So that will be 17.32 t squared plus 26. Along the y direction, that will be f times sine 30 degrees. So that's 10t squared plus 15 Newton. And then, of course, you have the normal force. Right now is an unknown. And then the motion is to the right. We have frictional force to the left. So because there's no motion along the vertical direction, resultant force along the y direction equals to n minus 98.1 minus 10t squared plus 15. That's the vertical component of the force. And that equals to 0. Therefore, from there, you can solve for normal force, which is also a function of time. And that is 10t squared plus 113.1. And because the kinetic friction coefficient is given, therefore the frictional force equals to mu k, and that is also a function of time, and that is 1.5 t squared plus 17.0. Therefore, the resultant force along the x direction equals to, we have the applied 17.32 t squared plus 26, and then minus the frictional force 1.5 t squared plus 17, and that equals to 15.82 t squared plus 9 in the is a function of time. And now we're ready to apply the principle of linear impulse and momentum. So we already said that 10 times 3, that's the initial linear momentum along the x direction, plus integration from 0 to 6, 15.82 t squared plus 9 dt equals to 30 plus, this is a polynomial, so 15.82 over 3 t to the third power evaluated from 0 to 6 plus 9.6, and that equals to, on the right hand side, 10 times v2x. So from this equation, we can solve for v2x, which is 122 meters per second. If you have time, you can try to solve this problem using Newton's second law and kinematics as well, and see if you can get to the same answer.